Hello students. In our previous class, we had a discussion about set theory. That is chapter number 1 in our class 11 mathematics. Let me brief it once again what is that set theory and what we have discussed in our previous class. Here the definition of sets is nothing but a collection of well-defined objects. Here well-defined, the word is very important. I told you and we have seen many examples. Set are denoted by capital alphabet. So sets are denoted by capital alphabet. Any set you can take. The sets always we represent with the capital alphabet, like capital A, capital B, capital C, capital A, and so on. And here we said the collection of well-defined objects. So objects are nothing but called elements of a particular set. And elements are denoted by lowercase letters of alphabet. Means like small a, small b, small c, small m, small x, small y, and small z. Sets can be represented in two ways. One is list form, another one is rule form. These are the topics we have discussed in our previous class. Now today we are going to discuss about types of sets. What are the types of sets we have? How to represent them? How to identify them? That we are going to learn in this class. Let us see. Now, today our concept is types of sets. How many types of sets are there and what are they? First list we have. The first one we have finite set. And the second one I have infinite set. And third one we have singleton set. And fourth one we have null set. And fifth one we have equal sets. And sixth one we have equivalent sets. So basically these are the types of sets we have. The first one is finite set, infinite set, singleton set, null set, equal sets, equivalent sets. Now let me discuss one by one how to identify the given sets are finite or infinite or singleton or null set or equal set or wide set or equivalent set that we discuss now. Let me discuss the first set which is called finite. The name itself we have finite. Finite means what? Countable. In which set we have countable number of elements? In which set we have countable number of elements? That set is nothing but called finite set. Finite set means set should consist of countable number of elements. Set should consist of countable number of elements, which is called finite set. For example, A is equal to A, E, I, O, U. How many are there? 1, 2, 3, 4, 5. So 5 numbers. That is nothing but countable. So any set which contains countable number of elements is nothing but called finite set. Now whatever infinite number of set, easily you can say which set contains uncountable number of elements. Set should consist of uncountable number of elements. Uncountable means infinite. For example, set of natural numbers. How many natural numbers we have? 1, 2, 3, 4 and so on to infinite. Here the number of natural numbers are uncountable. That is nothing but called infinite set. So finite set means what? Set should consist of countable number of elements. In which set you have countable number of elements, that set is nothing but called finite set. In which set you have uncountable number of elements, that is nothing but called infinite set. Now singleton set. Single means what? One. So set should contain only one element. Set should contain only one element. That is nothing but called singleton set. For example, even prime number. Collection of even prime number. How many even prime numbers we have? Only one. What is that? I can say set 2. Here how many elements we have? Only one element. So what we can call it as? We can call it as a singleton set. Similarly, you can have neither positive nor negative. How many numbers do we have neither positive nor negative? Only 0. Here also we have one element, that is called singleton set. The another one I can say that which is neither prime nor composite. A number which is prime, neither prime nor composite. Means that the number should not be a prime number, the number should not be a composite. Neither prime nor composite. How many numbers do we have? Only one number. What is that? 1 is the number. So I can say that C is equal to 1. If you observe here in this set I have only one element, here in this set I have only one element, here in this set also I have only one element. All these sets are consisting of only one element. That is nothing but called singleton set. Now you can say the null set. Very easily you can tell. Null means what? Empty. See, this null set is also called empty set or void set. Null set are also called null set or empty set or void set. These are the three names: null set, empty set or void set. Set should not contain any element. No elements in the set. No elements in the set means if there is a set A, if I take like this. So now here I have only brackets. These brackets represent set. Within that set, do you have any element? Are you able to find any element? No elements are there. So no elements are there in the sense which is called empty. Here it is empty. We are able to find what here? Empty one. So this is nothing but called empty set or null set or void set. So what is the definition of empty set? Set should not contain any element or no elements in a set. That is called null set or empty set or void set. Null set or empty set or void set can be represented pi. We can call it as what? Pi. This symbol represents null set or empty set or void set. We can read it as pi. So finite null set. Now finally we have equal sets. Equal means what? Compare. To compare anything, definitely we need minimum two quantities. Comparison. There are two students. I can compare with their marks, I can compare their age, I can compare their height, I can compare their weight, anything I can compare. So to compare anything, definitely we need two quantities. Similarly, when we are discussing about equal sets, here also we need minimum two sets. When we have minimum two sets, so that I can observe those two sets and I can decide whether they are equal or unequal. So now I want two sets to compare. Let us consider two sets I am taking here. Equal sets. Set A, I have the element 1, 2, 3, 4. Set B, I have the element 4, 2, 1, 3. Now, these are the two sets I have. Once, if you observe here, set A, how many elements do you have? 4 elements. Set B, how many elements do you have? Again, 4 elements. Both sets are having equal number of elements. Both sets are having equal number of elements. Now, observe the elements, how they are. Whether do you have same elements or different elements. First condition, what we are checking? A and B are having same number of elements. Same number of elements. And second condition, whether do you have same elements or not. Here what is the first element? 1. Here also I have 1. 2 I have. 3 I have. 4 I have. And I have A and B are having same elements. Here you may think that, sir, here first one is a, here 4 is a, here 2, 2, 3, 1, 4, 3. Order is not important for us. Order is not important. Order may be different, but you have to observe that whether you have same elements or not. Here I have 1, 2, 3, 4. Here also I have 1, 2, 3, 4. So here I have 4 elements. Here I have 4 elements. Here I have 1, 2, 3, 4 elements. Here also I have 1, 2, 3, 4 elements. So finally, how many conditions we are observing? 2 conditions. Condition number 1, A and B are having same number of elements. Condition number 2, A and B are having same elements. So that I can say that A is equal to B. I can say that A and B are equal sets. Equal sets means you should remember 2 conditions. Condition number 1, whether the sets are having same number of elements or not. Condition number 2, the sets are having same elements or not. Here I have same number of elements and same elements, so that I can say that A and B both are equal sets. That is about equal sets. So equal sets means we should compare same number of elements, same elements. That is called equal sets. Now what about equivalent sets? Equal and equivalent. Equal and equivalent. Now how to discuss and how to identify whether the given sets are equal and equivalent. Now A is equal to 1, 2, 3, 4. B is equal to A, B, C and D. Now you observe this. How they are? Set A consisting of 4 elements. Set B also consisting of 4 elements. Both sets are having same number of elements. Same number of elements, not same elements. Condition number 1, A and B are having same number of elements. And condition number 2, A and B are not having same elements. So a slight difference between equal sets and equivalent sets. Equal sets means it should satisfy two conditions. Condition number 1, same number of elements. Condition number 2, same elements. Equivalent sets, same number of elements but not same elements. Here I have 1, 2, 3, 4. 1, 2, 3, 4. Both are having 4 elements. But here the elements I have 1, 2, 3, 4. Here the elements I have A, B, C, D. So this kind of sets are nothing but called equivalent sets. So A and B are called equivalent sets. A and B are nothing but called equivalent sets. So here A and B are equal sets. Here A and B are nothing but equivalent sets. These are the 6 types of sets we have. Still more we have, now we discuss. So equal sets means same number of elements, same elements. Equivalent sets means same number of elements. Elements no need to be equal. Elements are no need to be equal. Now we have another type of set, that is 7th one is cardinal number of a set. What is the meaning of cardinal? Simple definition. Now let us see. A is equal to 1, 2, 3, 4. Cardinal means number of elements in the set. How many elements are there here? 4 elements are there. How to represent it? Simply I can represent n of A is equal to 4. This is nothing but called cardinal number of a set. Cardinal number means number of elements in the set. How many elements do you have? 4 elements. What are they? 1, 2, 3, 4. So that we can represent symbolically n of A. N of A means cardinal number of A. In another way, usually we call it as number of elements in A. N of A is equal to 4 means what? Cardinal number of A or number of elements of A. Now again, B is equal to. Now tell me how many elements are there here? Only one element. How can we represent it as? N of B is equal to 190. C is equal to what it is? Empty set. How many elements do we have here? No elements. So N of C is equal to 0. As we know that empty set usually we denote with pi. Pi represents what? Empty set. So N of pi is also nothing but 0. So these two gives us same. Here we have taken empty set and here we have taken the symbol. So N of pi is equal to 0 means number of elements in an empty set is 0. So cardinal number means number of elements which are presenting in a set. If you have 4 elements, we can say 4. If you have only one element, we can say 1. There is no element, we can say 0. So cardinal number is possible only for a finite set. which is not possible for infinite number of sets. Why infinite? Infinite means countable. Then how can you say that how many elements are there? Whenever they given any infinite set, your answer is always infinite. So there is no question for cardinality for a infinite sets. So cardinal number is only for a finite set. So cardinal number of a set means number of elements which are presenting in a set. Next we have another concept, subset, set. So what is the meaning of subset? Here easily you can say that sub means is a part. For example, we have a class 11. Where is this class 11? It is a part of a school. Where is this school is located? This school is located Kottur village. Where is this Kottur village? It is there in Hindupet Mandal. Where is this Hindupet Mandal? Which is there in Nellore district, which is there in AP state, which is there in India. Now tell me, there is a order for us. What is that? We are talking about class 11. So class 11 is a part. Where is this part? So class 11 is a part of a school. School is a part of a Kottur village. Kottur village is a part of a Hindupet Mandal. Hindupet is a part of a Nellore district. Nellore district is a part of a AP state. AP state is a part of a India. All these are nothing but parts. Means we have first India. In that we have AP. In that we have Nellore. In that we have Hindupet. In that we have Kottur. In that we have school. In that we have a class 11. So this is the sequential order. First India. In India we have AP. In AP we have Nellore. In Nellore we have Hindupet Mandal. In Hindupet Mandal we have Kottur village. In Kottur village we have GVKCV school. In GVKCV school we have a class 11 students. Means what we can say here, our class means class 11 is a part of a school. School is a part of a Kottur village. Kottur village is a part of a Hindupet Mandal. Hindupet Mandal is a part of a Nellore district. Nellore district is a part of a Andhra Pradesh. Andhra Pradesh is a part of a India. Like that, we have a subset. For example, students in class 11th, collection of students in class 11th. Now we have 10 students. Let us take Akhtar, Irfan, Manjuna, Bhaskar Datta, Narendra, Irfan. Like that, we have 10 students. All these 10 students are a part of a school. School, how many students are there? 600 students. Among all 600, you 10 are belongs to class 11. Means you 10 students are a part of 600 students. Basically, we all belongs to the Chinmaya school. Then we come for class wise. In that, class 11th is a part of a school. Similarly, here we have a subset. Now, if you see that I have natural numbers. I have natural numbers. So natural numbers are 1, 2, 3, 4, 5 and so on. If I take collection of even numbers 2, 4, 6, 8, 10 and so on. If I take collection of odd numbers 1, 3, 5, 7, 9 and so on. If I take collection of prime numbers 2, 3, 5, 7, 11, 13. If I take collection of composite numbers 4, 6, 8, 9, 10, 12, 14 and so on. Now you observe here, natural number is the biggest one. Even numbers are a part of a natural numbers. Odd numbers are a part of a natural numbers. Prime numbers are a part of a natural numbers. Composite numbers are also a part of a natural number. Means while comparing all these, which is the biggest one? Natural number set is the biggest one. From these natural numbers, even numbers, odd numbers, prime numbers, all these are what? Parts. So even numbers is a part of a natural number. Means here natural number we can call it as a set. From that set it is a part, so that we can call it as a subset. So even number is nothing but subset of natural numbers. Odd numbers is also a subset of a natural numbers. Prime numbers is also subset of a natural numbers. Composite numbers are also subset of a natural numbers. So subset we denote with a symbol. So this is nothing but symbol for subset. Here I can say that even numbers are subset of natural numbers. Odd numbers are subset of natural numbers. Prime numbers are also subset of natural numbers. Composite numbers are also subset of natural numbers. All these are parts of a natural numbers. Similarly, we have natural numbers. Natural numbers are part of a whole numbers. Whole numbers are part of a integers. Integers are part of a rational number. Rational numbers are part of a real numbers. So in that case also we can say that natural numbers are subset to whole numbers. Whole numbers are subset to integers. Integers are subset to rational. Rationals are subset to real numbers. So means all natural numbers are whole numbers. All whole numbers are integers. All integers are rationals. All rationals are real numbers. So this is about the concept of subset. So just we can stop up to here. In our next class we discuss how to find the number of subsets and what is the formula for number of subsets. That and all we discuss in our next class. Hari Om. Thank you.